Another aspect of this talk could be, could Dapr be something that aid you in abstracting away that complexity or giving you some form of simplification, giving you the means to focus on business needs? So, as Andreas said, Dapr stands for the Distributed Application Runtime, or you could also say a serverless runtime for hyperscale distributed systems. So there is a lot going on here. And currently, it's under community development in a preview phase. Version 0.8 is going to be released next week. And when we say community development, it's an open source project taking all kinds of contributions. I will mention different communication channels and where to find and engage later on in this presentation. But let's start talking about a simplification of distributed application. So you might have been doing some service-oriented things, or in the last years used the term microservices, and you have then done distributed applications. So let's look at a simplified picture of what a distributed application could be, or a service within. So you have this application and you want to communicate it using request response. And that's kind of basic, and you also want state, and you might also want to react to something, being more event-driven, saying that when something happened in the outside world, I want to react, and maybe I want to send some signal or event so other pods could react. And we could call that a binding for now. And binding, of course, could be an input and an output. And in some cases, simple binding as a reaction is not sufficient. Then you might want to have a more traditional broker system or messaging through a pub/sub. So then you have subscribers and you have publication from the same app. So now you have a notion of communicating with the app. You could react to the outside world in different fashion. You want a database, and that's basically a part of a system. It could be a whole application or a service. But if you have multiple of these applications or services, they might want to call upon each other. And we could call that an invoke, to use some logic or distribute a process between. So there is a few patterns around here. How could we build this kind of service or application that has all these responsibilities? And if you then go, in this case, to Azure, for example, every kind of technology that you adopt might do things differently. So you can have a service that has an SDK. How do you do binding? How you communicate with your data? You might have a runtime on top of something that does something. And most commonly for our developers is to drag in packages and SDKs to establish protocols or communicating with the outside world. So is there a possibility that we could get a more unified programming model, abstracting away the infrastructure, so we have this more common ground? So let's see what Dapr brings to the table, both in Azure, and to be clear, these are just examples from Azure. Dapr is something that spans outside the cloud and in multi-cloud environments. So Dapr is a sidecar architecture, runtime running as a sidecar. So first, what is that? So side by side with your application, you now have Dapr running. This could be a container, this could be in process. But meaning this is now side by side, you could at the local network call upon Dapr. So instead of having the application having request response and then cater to all the different distributed needs, you could now expose your application, but then the application could also react and communicate with the sidecar that is running Dapr. And in this case, Dapr could talk to some persistence layer or state in this case. And Dapr could also handle bindings, reacting to the outside world, both in fashions of streams or events or messaging through pub/sub brokers and managing state. So now your application could focus on business code and serving what they could have as a public API. And Dapr also handles the case that you want to invoke another service, and this, of course, involves knowing where does this actual service live. So in this case, you could, through your application, talk to Dapr that invokes another service through their sidecar running Dapr also. So here you could assume that you have some form of service discovery or some form of a DNS happening. So services don't know where they live, but you could call upon them using Dapr. So now you see a few very common patterns that is now fulfilled by this sidecar runtime. But there is a lot more to Dapr than this. So you have secrets management, and you have observability. So when you talk to the sidecar and let the sidecar talk to other sidecars, you have distributed tracing available. So you can have tracing between systems and between other infrastructure components, and Dapr handles that. So you don't need to have any of that in your application code, and secrets is also one simple API. And all traffic that runs through the Dapr sidecar could also apply a middleware chain. So here you could have some form of authentication or other middleware running. And there is also an actor implementation that is implemented in the sidecar with an API, so you could have concurrency and a lot of other things that actor brings to the table. So what is going on, and how do I enable all these building blocks? So when you enter some Dapr-enabled development, you will refer to these blocks as components. So in this simple example, you see that I have a components folder, and they contain some YAML configuration. So basically, components are a specification in YAML that you just configure. So that's all you're going to see when you're running your application. This means that SDKs are not needed. You have one common programming model to interact with these building blocks. We're going to look at that later. So let's go and look at one of these YAML files. And now you see something familiar if you're coming from the Kubernetes space. So here you see that I have a binding utilizing Azure Event Hubs, and you have some key value configuration to set that connection up. So now you see that you have some form of specification that the binding implements, that you just could configure different components. In this case, a written component for Event Hubs. But before we move further, we need to talk about a few standards that are surrounding Dapr that Dapr utilizes. One of these things are cloud events. Cloud events are a standardized envelope type for events. So when Dapr communicates through their pub subcomponent, every event is then wrapped in this cloud events standardized envelope. And we're going to see a few things moving forward where we are touching about new standards that Dapr utilizes. So cloud events is, as I said, a simplification, an envelope, but a standardized envelope that could have different serialization data, but the specification is still in JSON. And we're going to see how this is used. And all communications between your application and the Dapr sidecar is going to be either through HTTP or gRPC, depending on how you configure it. And this also opens the door to have bridges between HTTP and gRPC going through the sidecar. But let's don't get ahead of ourselves. So let's take a further look at the standardized protocol. So in this case here, we are now talking about the binding components. So I have a component that has a metadata name sample. That is an input binding. Then Dapr is going to receive some form of trigger by the binding that is going to invoke an endpoint in our application that is named sample. So you see now a correlation between the name sample and an endpoint name sample that's going to be invoked. And for all bindings, the payload is bytes. So now you could configure anything that is a component in Dapr that supports an input binding, and it's going to invoke an HTTP or gRPC endpoint on your end. So now you could interchange this binding. And the same way goes when you need to communicate out with a byte payload. Then you are going to utilize an output binding, and even that is configured through a component, or in this case, the same component sharing the name sample. And now you see this schema, how we communicate with the sidecar. So I'm going to invoke the sidecar using the local host because this is running side by side, and the sidecar has a port and a version, and then we have the schema of bindings, and lastly, my name sample. And this is how I invoke the component running in the sidecar. So you see that it's strictly gRPC, or in this case, HTTP. So everything that could call something in HTTP could utilize Dapr. So your application, as long as it understands gRPC or HTTP, could utilize these kinds of sidecar components. The same goes for PubSub. So the difference here is that you still have a component, and the component is of PubSub type. The only thing that is changed here now is the payload. So now we have this payload in Cloud Events format that is JSON. So I'm going to register within my app what kind of topics that I need to subscribe to and the endpoint that corresponds to each topic. Then when Dapr receives a message through that broker, or it's going to invoke yet another endpoint, in this case also named sample. And if I'm going to publish an envelope or a payload, it's also done through the schema, but this time instead of publish, we're going to post through HTTP to an endpoint under publish sample. So now you're going to getting to know the abstraction. So you could gRPC or HTTP to the sidecar, and you see some correlation between naming and the underlying API here with bindings and publish. And this also goes that you could invoke things through your sidecar, and that could be any payload. And as you see the URI on the top here, we're now swapping out the publish and bind and using the keyword invoke and adding a few slugs here to the URI with our application ID and the method name. And now I could invoke a method in another application talking to my sidecar that then does some service resolution where the other service lives, invokes that through the sidecars and into the application. And here you could see the possibility to bridge things between HTTP and gRPC. And remember, while we're doing this, we have added retry policies, traceability, middleware, everything that you could configure in your sidecars is going to be in the chain here when you invoke services. So your application code is going to look rather simple, just invoking URIs through HTTP or gRPC, but a lot of things is going to get done across the wire here using Dapr. So to summarize, what Dapr is a set of building blocks or components that runs in a sidecar for service-to-service invocation, state management, publish and subscribes, bindings, triggers, actors, distributed tracing, and secrets. So then we have this term that you're going to see that is Dapprize. So you don't need a greenfield project to start with Dapr. You could run any process or container and place the sidecar and introduce Dapr partially. So every component in Dapr, you could easily just start using one thing and then Dapprize. And we're going to see this term also used when you could have another container or another application that could utilize Dapr in other ways. Let's see that later. So what is Dapr actually? Dapr is written in Go. So if you want to implement components that we looked at, there are specifications for the API surface, and you could go implement any kind of state, PubSub, binding, configuration, things like that, secret stores, following the specification, and then contribute this to Dapr as a Go module. But when running this both locally for development, there is a CLI aiding you in communicating with the sidecar. And the most common command, of course, when you develop is to run something local. Then you use the CLI Dapr run, and as you've seen before, you give applications an ID for resolution, and you saw this invoke URI that also uses this ID, in this case, demo application. Then you give the application a port so the sidecar knows how to communicate with that, and then the command to run it. So in this case, we're running some .NET Core application that is now utilizing the Dapr sidecar. And the CLI also has some utilities, and if you're familiar with curl and things like that, you are now going to see some overlap. Actually, could use invoke and publish to talk to the sidecar to simulate invocation of endpoints and also publishing messages from the CLI. And this comes really handy when doing local development, because now you don't have to set anything up. You just run your Dapperized applications through the Dapr CLI, and then you could start publish or invoke things through the CLI to test your service or application. And of course, you could also list every service that is running, and here you see the different ports for HTTP and gRPC, and the name and what command that has executed that application. So let's continue and see more about the developer experience and the tooling taking form around Dapr. So I have said a few times that Dapr is agnostic to the use of the SDK, but you're going now to see that there are also SDKs for utilizing Dapr. So let's see what those bring to the table. So let's start with a simple application here in Node using no SDK at all. And now we're going to write an application that uses Dapr for its pub/sub capabilities. So if you look at the first route here, you have an get endpoint that says Dapr is going to call this endpoint and say, what topics do you want to subscribe? In this case, I want to subscribe both to topic A and B, and then I define a route saying, when you get the message on topic A, invoke route A, and the same for B. And then later in the code here on line 28 and 33, you just see two standardized HTTP endpoints on the post processing the message. So this is basically it. If you run the sidecar, you have a pub/sub component, and if you don't have already, Redis is the de facto go-to when you have local development. So if you have installed Dapr, you could just run this code and start Dapr publish and try this code out. So this has no SDK, it's strictly HTTP, so you don't need anything if you know what endpoint conventions are. But moving on, let's see how we now could utilize the Dapr SDK for .NET Core. So now we have an SDK that has some utilities for .NET Core, and see how that is going to be different from the node sample. So in this case, we register some controller annotations with Dapr, and you also see in the app configuration that we're using middleware for the cloud events envelopes. We have some authentication that comes along, and also the Dapr specific map subscribe handlers. So this is our startup for now that is Dapperized through the SDKs. So now we're going to use controllers together with pub/sub. And the controllers now could look like this. So now I have some annotation here with a topic attribute saying that this endpoint is going to be called when I receive messages on the topic sample. And the other sample you see here is if you utilize a binding, we now have a strict convention that we're receiving something through a hub binding pointing to event hubs. And we see what the SDK brings in the pub/sub example, because now the Dapr SDK will give us that endpoint that tells Dapr on what topics we want to listen, and this controller endpoint is now going to be invoked upon receiving messages on the sample topic. So now you have strict HTTP endpoints, and you just annotate them with the sample and configure something at startup. And for the binding types you see down below here, you don't need anything. You just follow the convention that the hub name of the binding is going to be invoked. So that's just a small slice of what the SDK could bring. Of course, when you're talking about actors and the secret stores and publishing out to PubSub or bindings, there are a few utility clients and things like that in the SDK as well, of course. And around this setting up components and new projects, starting greenfield with Dapr, we're also seeing contributions using things like Yeoman. So let's take a short look how you could utilize a tool for Yeoman, introducing a few applications with Dapr. So here you see someone making 5 different services using 5 different languages and also configuring a few components. And then opening that solution and see what Yeoman has generated in this case. And this could be a great tool to just familiarize you with the different usages of configuration and components and have a look how it differs language to language in this case. And also, as you saw that there briefly, and here it also generates a full README for each service, how to run the Dapr CLI using that service. And now, lastly, you see they use the CLI to list the applications. We have a Python application and a Go application. So there is support surrounding this, things like Yeoman, and we're now seeing things in Visual Studio Code, debugging capabilities, a lot of container extensions, and things moving forward to utilize Dapr as a first-class citizen in this experience. And the same thing, I assume, will come to other IDEs like Visual Studio and such. And you also see there are other libraries and utilities out there for generating, in this case, a dashboard. There is also dashboards for graphs and some things already set up. So there is a strong hint in the community around different UX and dev tools that is going to utilize Dapr in different forms. And one of the key targets in the current perspective is to be able to utilize Dapr in current Kubernetes environments. So if you install Dapr in your Kubernetes cluster, you're going to get 4 different services installed: the actor placement service, the sidecar injector, and the operator and sentry module. And this allows you to then add annotations to your Helm charts to deploy Dapperized applications. So one of the goals here is, of course, making it easier to do distributed applications in orchestrators like Kubernetes. And when you are in an orchestrator or running in some form of a cluster, you need to have some form of ingress. And commonly you have some application gateway, Nginx traffic, or proxy of some sort. Or in the future, you have this project JARP in the .NET space. And now you see another utilization of the word Dapperize, because you could now go and run Nginx in one container and side by side run Dapr. And now, instead of letting Nginx just route your traffic to your actual application, it could now invoke Dapr instead. So Dapr does the service registry resolution and calls your actual application sidecar to sidecar. So now you have invoked both the possibility to have distributed tracing and all the middleware pipeline running in Dapr between your ingress proxy and down to your Dapperized application. So now you could use things like OAuth authentication running in the sidecar configured for your ingress proxy and getting this distributed tracing also without touching any code. So here you see an excellent example bringing some other technology and Dapperize it because it communicates through gRPC or HTTP. And now we're going to touch about yet another kind of new specification that is surrounding Dapr. The first was the cloud events. And if you're familiar with Kubernetes or other deployments of application that have different flavors in languages, how you describe both your application and your infrastructure. So Open application model is now one specification to describing applications from mainly a developer's experience. So it's a team-centric standard for building cloud-native applications. And why I mention this at this point is that Dapr does not rely on open application model, but I think it's an important building block that we're going to see in the future, how you could use something like Dapr to set up your applications using components, and then using yet another standard to describing that application using the open application model that is agnostic to the underlying technology that you're going to deploy this on. So now you have cloud native for real, because you don't know if it's going to be Kubernetes, if it's going to be something else. So you have Dapr on the one hand, and you have the OHM specification on the other hand. So please go and take a look. But just to stress things out, Dapr is not dependent on OHM, but they are, from my perspective, kind of related. So let's look at a few scenarios how we could use Dapr. So, as we said, OHM and Dapr is aiding to provide developers with tools and abstractions so we could design and develop their cloud-native applications in an agnostic way, both of infrastructure and cloud. And the target here is, of course, because we're talking about cloud-native, both cloud and edge. And I could also stress that Dapr runs also in process, so you could run it basically anywhere. So it's not dependent on cloud in that fashion. So this could be a case, you're developing an application, you're using the Dapr sidecar, and you're running this locally. Now you're running Dapr, and you're running Redis, and you're running this through Docker containers. You could now use things like curl to talk to your application using any protocol that the application exposes, but you could also utilize Dapr CLI and now invoke services and publish messages, directly invoking things in the sidecar and testing out your application from the sidecar perspective. And if you go one step further and now look at the interchangeability of components, you could now have like a state component locally that uses Redis. And then when you go to Azure, it uses the Redis service. And when you go to production, for some case, that could be changing a binding from Redis to event hubs, or changing the Redis state store to a Cosmos store. So every component is interchangeable, so you could swap them out. But on a note, when we come to bindings, some bindings could be more specific. So if you're utilizing a binding to communicate with Twitter, that is not that interchangeable. But if you're using different state stores and moving from Redis to Azure storage or to something AWS store, something like that, it's interchangeable. But bindings might be more pinned. But you get the picture here that you could make a cloud-native application, and it doesn't really care what component that fulfills that specification. As long as it's a Dapr component, you could then change them out between environments. That means that you develop and deploy the same application for two different clients using maybe two different state stores. Another common thing is that you could have some stream processing where you're enriching events coming through Kafka or Event Hubs or Google Pub Sub, something like that. Then you have incoming data and a component for that Dapr listens to. And now you have some data that you want to enrich that with. So now Dapr abstracts away possible the state where you have this enrichment data. So you just write an application that invokes an endpoint on incoming data, utilizes the state API to get that data, and then you have this railway system out that you could push valid data through one binding and invalid data out to another binding. So now you have abstracted away everything about the distribution of your enricher, utilizing Dapr for both bindings and state in this case. And this is a quite common scenario. Now we're going to see another example following along the Daprization that we saw with Nginx. And this time it's workflow applications, and in this case, logic apps in Azure. So logic apps is software as a service offering within Azure, but recently it's also NuGet packages using the same workflow engine. And since that workflow engine is invoking endpoints at different states of its process, we could now run that in a container or in one process with Dapr side by side. And now this workflow engine could call into Dapr and invoke applications in different workflow steps that is Daprized. So imagine now that you could have resolution of services from your workflow that utilizes Dapr, and it has also distributed tracing enabled. So now you could run workflow within your applications with Dapr side by side, in this case, invoking another application. So there are many possibilities where you have standardized runtime or apps that invokes gRPC or HTTP that is from the get-go possible to Daprize and letting them communicate through a sidecar utilizing Dapr to get all the benefits of that pipeline. And let's take another scenario where you have an event-driven application that is listening to some form of integration events from another application to drive a process forward, and in this case also publishing integration events when this part of the process is running. And now we have this Dapr state store utilizing Cosmos. So one possible future scenario is that I both could use Cosmos through the Dapr state API and at the same time utilize the same Cosmos database as an input binding, subscribing to the change feed, and in this case implementing some form of outbox pattern here for my events. So I'm storing events in Cosmos, I'm subscribing to the same Cosmos database, I'm utilizing the state API and an input binding, and then also I could use output bindings here or pub/sub in communicating out my events in this way. So this, I think, is really interesting to mix technologies where there might be both bindings and state, and having these patterns being able to more or less remove all SDK needs for my application in this quite complex scenario. But let's dream up a more advanced scenario that is more a fiction of imagination. So the Dapr state API is a key value-based API. And let's say that we want to use storage or a database that is not catered to key value. So in this case, we're going to use the event store database as an example, and saying, I could write a component that fulfills the Dapr state API utilizing event store, possibly, but it might not be a good fit. At the same time, you could have a binding for this database saying that you could at least use the Dapr bindings to subscribing to changes. But you could actually now both argue that you might write a component, or the community should write a component, or in this case, you might actually in your application use the event store database SDK and at the same time use a binding. And you could, of course, when things get this advanced, run the APIs of event store as another service and invoke them through Dapr. So maybe this is not the most clear-cut example, but I just want to show you that there are fits where the abstractions of Dapr might not match, and you have possibilities to, of course, include that SDK or work around it in Daprizing another component. But this technique could also have other areas where components are supported. So it's going to be really interesting to see what kind of techniques or technologies that is going to be easily adapted by the Dapr APIs and where it's not quite a good fit. And on that notion, you should also be aware of that the bindings I have shown you now are quite simplified, and there is work in progress letting output bindings support different kinds of operations. So in the future, there might be possibilities that bindings could overlap and actually could execute a few things specifying operations on the bindings. So let's see whether what we end up with that. So a few weeks back, there was the Microsoft Build conference, and of course Dapr had some presence there. And if you want more examples, one of the examples that were shown at the Build is Twitter incentiment application, and you could find the source code and more demo applications through the Dapr YouTube channel if you want to look at more examples in code. And now you might start wondering in what kind of state is this? When could I actually use this? So as I said, version 0.8 is going to be out the door anytime, and the team and community is working forwards a stable specification for 1.0, and that might be in the time frame of the third quarter. And when you have that stable, it's ready for production workloads. But let's see what kind of environments and services that is going to be adopting Dapr in this case. That moves us into the area of rumors and speculation on my part. So as you've seen, one target, of course, is current Kubernetes usages. So if you have any AKS installation or running something in a container engine and anything using Kubernetes, the target is that you're going to be able to Dapprize your services and taking advantage of all these things as soon as possible. It's possible even now, but then you could speculate in other services within Azure that is part of distributed systems. How could Dapr move in and fill that application model? So there are rumors that there are going to be something announced in the next coming weeks around Azure Functions and how Azure Functions and Dapr could collaborate. And then you could speculate that maybe app services within Azure could also have this application model at hand. Of course, container instances is already possible in some form to get Dapr running there. And my favorite is the, of course, super speculative replacement for the Service Fabric Mesh product, where you might have a serverless offering combining open application model and Dapr as first-class citizen, abstracting away a lot of the complexity in running your Kubernetes workloads. Maybe AKS will fulfill that in some other way. And of course, things like Service Fabric could also implement and make use of Dapr, so you could lift and shift things in and out of Service Fabric as well. And this is only Azure, for example. So make no mistake, every other cloud service or anything that's targeting Kubernetes or running containers in any form, or for that case, VMs that could have in processes, everything supports Dapr that could run a container or something side by side in process. Let's just focus on what kind of cloud offerings that could have Dapr as a first-class citizen. So to recap, what we've seen here is Dapr as a sidecar with the different components for service invocation, state management, pub/sub, bindings, actors, tracing, and extensibility, going over protocols HTTP and gRPC, making it possible for you to write applications in any language that supports either gRPC or HTTP. Some languages will have SDKs for actors and wrapping some of those components, but you don't need them if you could talk HTTP and gRPC. It's just a higher level of abstraction. And Dapr could run on any cloud or edge infrastructure as long as it supports in-process or containers. So to find out more, go to Dapr.io or engage with the community through Gitter, and you could browse all the Dapr repositories, the samples, components, documentations, and things like that, and file issues and look at the roadmap through GitHub Dapr. And there are community calls. I think it's bi-weekly, so go and subscribe to the Dapr dev channel, and there you also find all the build samples that I mentioned. Of course, also go to Build and see the recorded sessions. You could follow Dapr Dev at Twitter. And there are also a book in the works through O'Reilly, and that is in early release. You could have a look at that as well. And with that, I hope you have gotten a picture of what Dapr is, and what is going on and what is possible regarding application development, debugging, and scenarios how you could utilize it, and where it might fit in different cloud offerings and how you could utilize this to simplify your application, to concentrate and collaborate about business needs, and hopefully decrease complexity when you are developing distributed systems. So with that, I say thank you, and we're open for questions. Andreas.
Thank you so much, Per. I think, unfortunately, we had some technical hiccups, so that's the first few slides were cut out from the broadcast. But yeah, anyway, anyone having questions? Once again, we are really sorry about these technical issues here today, but it's nice to finally see all of your smiling faces. Also, would like to remind that this is the season finale of our Wednesday broadcasts, and we're open for submissions for after the summer. We would love to hear what content you would like to bring, or us to bring for you.
And if you don't have any questions now, I could just repeat that any thoughts and discussions, head over to the Gitter channels for Dapr. There is a lot of talk of going on, and your questions will be answered there, and you could discuss this in further detail with the team and community there instead if you want.
Yeah. So maybe we should summarize and thank all speakers during the spring. Thank Madeleine, who has been leading all the previous sessions and giving me the opportunity to present here today. And thank you, Per, for giving this presentation today. And if you like 1337's videos, please give it a thumbs up. Hit the subscribe button. That way you get notified on upcoming content. And I want to wish everyone a nice summer.
Thank you.